for which was the technical graphics question, okay, of 2019 question 6. It is the ellipse and parabola question, and we'll get started on it here now, okay? So I'm going to start with the baseline. In light pencil, which will give me the base of the parabola. I'm going to just set up all of the imagery for where I need it. Okay, so this will be my center line for E and B. Okay, I know E is up 20 and B is up another 20, so I can label them in there. That's point B and that's point E. I know that A is out 80 millimeters and C is also out 80 millimeters, so I can measure out that far as well. Again, labels are going to be key to your success here. I don't know the measurements of D and F yet until I copy my parabola of ABC. Alright. I also know then from B is going to be a 60-degree line. I don't know how long just yet. 60-degree line. If I step up from B by 30 millimeters, it will give me the bottom of J. So stepping up by 30 millimeters. So I'm just following the instructions on the drawing. And that gives me, when my 60-degree line meets that horizontal line, gives me this point here, which then becomes J, which is a part of the major axis of the ellipse. Okay, we also know the angle then of our ellipse is going to be 60 degrees, so from J I can then draw a 60-degree line, again using sharp equipment, crisp lines. The measurement of that is going to be 85 and 85. So 85 gets me to the center of the ellipse. And if I double that distance, then I know that I'll get to the other end of the ellipse. Okay, and again that point is going to be known as L. The center of the ellipse can be known as O. And my my minor axis is then going to be 90 degrees to this line. So this line is at 60 degrees, so 90 degrees to that would be 30, and I'll draw that line in there. It doesn't tell me what length that line is, but I'm going to have to use my knowledge of ellipses in order to find the minor axis and the minor points of K and M. Okay, and again we'll explore that as it goes on now in a second. So that's pretty much my setup for now. If I wanted to start with the ellipse or the parabola, I'm going to start from the bottom and work my way up. So I'm going to start with the parabola. So I'm going to use my rectangular method. So I create a rectangle at ABC. Okay. A to B I know is 80 millimeters, which is easily divisible by 4. Not so easily divisible by 5, so that means that I don't have to use the division of lines method, but I still get 4 segments. Remember, the ball is going to start at A, go up to our vertex at B, and then the copy is going to land down at C. Again, the height of this parabola is 40 millimeters, so again I don't have to use division of lines, thank God, and I can just go with 10 millimeter segments. Okay? As we get further away from A, we're going to increase in number. So 1, 2, and 3, 1, 2, and 3. The axis, or the mirror line of this parabola, is the vertical line here. So that means that these bottom lines will go parallel to it. And again, I'll just maybe draw in coloured pencil here. Maybe just or coloured pen, just to highlight it a little bit. Okay. So our axis here is this red line. That is our axis. Okay. Now these blue lines, you always, when drawing a parabola, one set of lines will go parallel to the axis. So therefore, this set of 1, 2, and 3 will go parallel. And the other set, where did they go to? Where will these set of 1, 2, and 3 go to? They'll go to B. Or what we know as the vertex, the highest point of our parabola. So once they all find their paths, the ball is going to start at A, where 1 crosses 1 is a point, where 2 crosses 2 is a point, where 3 crosses 3 is a point. That there is my parabola. So I'll sketch them in. Joining them up as fluid and as crisp as possible. And now I want to copy them to the other side. Bring it up to me. You okay? Did you not have your hand up? No? Okay. So we're going to copy this across. We're going to bring that across, bring my 3 points across. How far do we go across? Well, it's a mirror. So whatever distance you are from the mirror, your reflection is the same distance the far side. So I'll take my compass here. I'll draw my reflection of that point. Take my compass, draw on the reflection. And take my compass and draw on the reflection. Then my parabola is going to continue on. It's going to come down now from B and hit these 3 points again. I'm trying to sketch it in nice and fluid. As fluid as possible. Thank you, sir. Okay, now the second parabola DEF is a portion of this. Now we know that this parabola ABC is 40 millimeters tall. Okay, and therefore, and we know that the base is 160 millimeters wide. With the second parabola, DEF, we know that it's 20 millimeters tall, but we don't know how wide the base is. So if I take that measurement from the original parabola, if I come down 20 millimeters, okay, so what I'm doing here is I'm coming down 20 millimeters, and my green line is going to cut that original parabola. So this green line that you're going to see is cutting the original parabola, like so. That gives you all the measurements and marks that we're going to transfer down. Okay, so I know that that is my base points for D and F. So wherever that is, I'll bring that down. That will give me F. And wherever this crosses a parabola here, gives me D. Now I need to copy this. I can't redraw because it needs to be a copy. So I'm going to transfer these 2 points down to where they need to go. So I'm going to go bring them down by 20 as well. Okay? So I'll bring these points down. And they're going to travel down the same distance as E did, and the same distance as these 2 points, travel down by 20. At least I should have. Yeah. Okay. So I'm going to bring this point down by 20, and that will give me a point on the new ellipse. That there is a point on the new ellipse. This location here, I'll bring it down by 20, and that will give me a location on the new ellipse. I'll take this point, bring it down by 20, that will give me a location on the new parabola. I keep saying ellipse by accident. I'll bring that down by 20, and that will give me a location on the new parabola. So for the new parabola, I'll sketch it in here. It goes from D to this point because all these points just traveled down by 20 because they're a copy. And so it goes from D to this point to E, and from E to this point to F. And that's an exact copy or portion of the original parabola. Is that okay? Alright, so that's how that is done. Now we're going to move on then to the next section, and I'm going to do the circle next, which is of radius 20 millimeters. So again, on B here, I'll measure out 20 millimeters with my pencil, put a little mark, and that will set up my compass to draw my circle. Okay. And again, I'm going to draw it in light pencil first, and then I can go over it at the end to make it stand out. So that's that there. Now the next challenge that I'm going to move on to is I'm going to draw the elliptical shape of the rugby ball here. Okay. And so we have J, O and L. That's the major axis. Okay. And we know the distance of P, and we also know the distance of N because they are focal points. They're provided in the question. So if I measure from O out 70, that gives me point P, which is a focal point. And the same distance, the opposite direction, will give me the other focal point, won't it? Okay, so that there is going to be N. Now, what's our rule? Our algebraic equation. We need the minor axis, the major axis, to find the focal points. In this scenario, we don't have the minor axis, but we have the major axis and we have the focal points. So how do I combine them to find my minor axis? Half the major from the minor gives you your focal points, doesn't it? So if I get half the major and I swing it from a focal point, it will give me my minor. There's the point of the minor on one side, there's the point on the minor on the other. If you want to test your theory, swing the same one from P and see if you get the same point. Exact same point. Making sure I have the right distance here. So half the major. There we go. Half the major from the minor. Those points there are K and M. K and M. From here you can use any technique you want to draw your elliptical shape. You can use your Trammell method or you can use your concentric circle method, whichever one you are stronger at. Okay, for me I'm just going to use the Trammell method because it's quicker. What do we always make sure we do with the Trammell? You tape to the sheet, okay? So for me, I don't need this whole sheet, so I'm just going to take a section of it. That's my Trammell. And I'm going to mark in the major axis. So this is going to be P, which draws the points. This is going to be 2. And from K to O, or from P to O, is going to be half the minor, half the major. And as I spin this around, guys, 1 must stay on the major axis, 2 must stay on the minor, and that's how I will draw my ellipse all the way around. The more points you have, the more accurate your curve is going to be, but it's going to delay you then a little bit because it's time consuming. So make sure to have a fine balance of that. So the key step in solving this ellipse, was the rule that we've mentioned several times, is half the major from the minor gets you the focal points. Or if you're missing the minor or major axis, you can use that information to find either one from the focal points. If you're missing the minor or the major, you can get it from the focal point. There's my elliptical curve done, so I'll join up all the points with a nice fluid crisp line, trying to not make it as thick as possible and making sure that the end points don't go like a lemon. It's a continuous curve, so we must draw it as a continuous curve. It is a rugby ball, remember, so a rugby ball doesn't have a fine point on it because it's a rugby trophy. So sketch it in accordingly, alright? That's my ellipse done then. So the stitching then is going to be in by 15 millimeters. So I'll step in by 15 either side at a 60-degree line. Don't forget to tape that tram to your sheet, otherwise you can lose marks. So in light pencil I'm drawing in my boundary for my stitching. Okay, and every stitch then is 15 millimeters as far as it goes up to the focal points. So 15 and 15 and 15. 3 stitches. 1, 2. Sorry, it's only 2. 1, 2, and 15 and 15. We're going to join from the focal point to this point here to get our angle. Do the same on the opposite side, get our angle. That determines the length of the stitching. And then at 30 degrees we'll draw in our stitches and we mustn't forget that the stitches go from P to N as well. Okay, so that's in a little bit heavier. Okay, the last thing then to complete this question, I have this line here from J to B, but I need to draw the tangent line here and find T. Isn't that right? So how do we do that? So what we're going to do is we're going to join the center of the ellipse to the center of to the point of the tangent. And if we're going to draw this line in green, I want somebody to tell me what to do with this line in green. I'm also just going to highlight something here. I'm going to highlight the distance from K to N. That distance there is half the major axis. Okay, that distance is half the major axis. So in order to find K or M, I set my compass to half the major and swung it from the minor to get me K or to get me M. That's how you solve and get the information you need to draw the ellipse. So to draw our tangent here at T, we're going to join O to B, because that's the center of the ellipse and the point of the tangency. Then what we're going to, okay, the rugby ball will only touch the roof, or if it hits the post, it will only touch the post at one singular point. That's the point of contact. All right, that's what we call it. So to draw this, what I'm going to do is I'm going to show you how to do this. All right. So we know that it's going to be tangential from B. Okay, and it involves our focal points. So what I'm going to do is I'm going to put my compass on B. I'm going to set it to the nearest focal point, which is N, and I swing an arc. Okay? Does that make sense? Yeah? And the next thing then that I'm going to do is I'm going to set my compass. Let me just double check this. Is from you're going to need this for next week. So where B is, we're going to set it up and draw an arc to the nearest focal point. Then I'm going to set my compass to the major axis, to the full major axis. Okay, now your compass might struggle to get that far, but it should do it. Alright? Like that, 160 millimeters. No, sorry, 170 millimeters. Then what I do is I put it onto the furthest focal point away, and I swing an arc. Like so. This arc needs to be continued here. We'll bring that round to there. Then what I'm going to do is I'm going to take this point here, where my two arcs meet, and I bring that to the far focal point. So this point will go and hit the far focal point like so. I'll do it in green. And wherever it hits the ellipse, that is our point of contact. And so therefore, I now have my tangency to B. That there is my tangent. I've uploaded a separate video of that onto the Teams group anyway, so you can study it over the next couple of days as well. Any questions on that? So what's kind of new in that is the copying. It's kind of new, it's not brand new. The copying of DEF, so moving ABC down. It's a portion of it. So what did I do? I stepped down by 20 millimeters because I know that's the height of E. So I stepped down by 20, cut it off, and this section in here, above the green line, that's what I was copying. So I just needed to move all of that shaded section there down by 20 millimeters. Does that make sense? Yeah? So I copied all the points, any points above that, and I moved them all down by 20 millimeters. Very simple. Okay, so the end point here where the green line is, the end point there, brought them down. They would give me D and F. That point, that point, that point, and that point, moved them down by 20 millimeters, and that gave me my curve. Okay, the ellipse should be fairly straightforward. Once we know the rule, half the major from the minor finds you what? Focal points. What piece of information was I missing in this question? Was I missing the focal points? No. Was I missing the major axis? No. What was I missing? The minor axis. So the same rule finds me the distance of the minor axis. So just to show you that again, half the major from the minor finds you your focal point, or works the other way around. From the focal point finds you your minor. Do you understand? Or if I had the focal point and the minor, I could set my compass to that measurement, and that would give me half the major. So you're always going to be missing one of those pieces of information. Okay? But the two pieces of information on the page will help you find the third. Okay? So that's that question, guys. Don't forget that if you're using the Trommel method, that it tapes to the sheet somewhere and doesn't fall off in transport. And that's your question fully complete.